Hello, awesome Algebra 1 students, welcome back. In this video, we're going to be factoring trinomials with the leading coefficient, this time using the supergrouping method. So if you have not already seen my video on slip and slide, you might want to check that one out first. It tends to be the favorite of the methods, but supergrouping is an equally effective method for this type of expression. So in supergrouping, you first start by multiplying the first and the last term. Then you use P's and Q's to split the middle term, so you go from a trinomial into a four-termed polynomial, and then you just factor by grouping. So if you are a fan of factor by grouping or GCF factoring, and that's something that you're really good at, I would highly recommend using supergrouping. If it's not something that you feel super comfortable with, this might not be the method for you. Either way, let's take a look at some examples. All right, so going through our examples here, all of these are trinomials where the leading coefficient is not 1. It is greater than 1, so that's how we know we can use supergrouping. So step 1, we're going to multiply the first and the last coefficient. So 2 times 10 is 20. Now we're going to do the P's and Q's game, but with a bit of a twist. The middle term is still the sum, but now that product of the first and the last term is our product in P's and Q's. So we ask ourselves, what plus what is 9, but what two numbers multiply to 20? So again, the only catch here is that you have to multiply the first and the last term to get that product. So those two numbers are 4 and 5, or 5 and 4, it doesn't matter. Now, here's the key part with supergrouping. You're going to use that P and Q to split the middle term. So this middle term, 9a, becomes 4a plus 5a. And where did I get that from? I got that from my P and Q. And again, this is a positive 4a and a positive 5a. So there's nothing much we can do with this without bringing down the rest of the expression. So I bring down the leading coefficient or the leading term, 2a squared, and bring down the last term, positive 10. So what we have done is we have gone from an expression with 3 terms to an expression with 4 terms. But these are equivalent expressions because if you add 4a and 5a, you still have 9a. Now, why on earth would we want to do that? The reason why we would do this is because you can only factor by grouping when you have 4 terms. So now I can go in and do my factor by grouping. If you have not seen the factor by grouping video, make sure that you watch that before trying to do this problem. Okay, so here we go. What's the greatest common factor of 2 and 4? That would be 2. So 2a squared is 2 times a times a. 4a is 2 times 2 times a. 5a and 10 have a greatest common factor of 5. So 5a is 5 times a, and 10 is just 5 times 2. So what do they have in common? In the first binomial, they have 2a in common. So when I factor out 2a, that leaves me with a plus 2. There's a plus sign here, I forgot. And then over here, they have 5 in common. That's a positive 5. And when I factor that out, I'm left with a plus 2. My common binomial factor here is a plus 2. So that will be the first binomial in my final answer. And then once I factor that out, I'm left with 2a plus 5, or in other words, the GCF of the other two binomials. And this, oops, this is your final answer. Now, the way that I can check, doing a quick mental check, a times 2a is 2a squared, and a times 5 is the 5a. 2 times 2a is the 4a, which if we add those up together, we get 9a, and then 2 times 5 is 10. So I know I did that right. All right, let's try it on example 2 here, number 28. So again, first step is we're going to multiply the coefficients of the first and the last term. 5 times 3 is 15. The middle term is always your sum. So now we get to play the P's and Q's game. What two numbers have a sum of 8 and a product, of 15? So what two numbers add up to 8 and have a product of 15? I think those two numbers are 3 and 5. Yep, 3 and 5. Okay, this is the key part. You can't do supergrouping with 3 terms. You've got to split it up into 4 terms. So we split the middle term into positive 3a plus 5a. Again, where do we get that from? We get that from our P's and Q's. And why do we do that? We do that because when we bring down the other two terms, we now have a 4-termed polynomial, which means we can factor by grouping. You don't want to try factor by grouping without a 4-termed polynomial. All right, so now we go ahead and we put in our groups, and we're going to find the greatest common factor of each. So what's the greatest common factor of 5 and 3? We don't have any common factors, which means let's just look for common factors in the variables. So 5 is 5, or 5a squared is 5 times a times a, and 3a is 3 times a. Over here, they don't even both have variables, which means we can always factor out 1 if we need to. So this would just be 1 times 5 times a and 1 times 3. We don't necessarily need to factor out 1 in the first binomial because they have a in common. So they have a in common here in the first binomial, so we'll factor out a. And when we do that, we're left with 5a plus 3. In the second one, as we noted, they didn't have any greatest common factors, so we're just going to factor out 1, and that leaves us with 5a plus 3. All right. Our common binomial factor here is 5a plus 3, so that's the first binomial in our final answer. Oops. There we go. And when we factor that out, we are left with the GCF of our two binomials, which were a plus 1. All right, we're going to do a quick check here. 5a times a is 5a squared. 5a times 1 is 5a. 3 times a is 3a, which if we add those up, we get a squared. And 3 times 1 is how we get 3. So we know that is not the shape I wanted. We know this is correct. All right, I'm going to skip number 29 because it's very similar to 27 and 28, and we'll end with number 30. Number 30, I didn't give myself a ton of space to do this, so that's okay. Multiply 3 times negative 6, and that gives you negative 18, which is our product. So we're going to find two numbers that have a sum of the middle term, so a sum of negative 7 and a product of negative 18. What about negative 9 and 2? Negative 9. Yep, negative 9 plus 2 is negative 7, and negative 9 times 2 is negative 18. Okay, most important step. Split the middle term. So our middle term is going to become negative 9x plus 2x. If I add these together, I should still have the middle term. We're creating an equivalent expression here. We don't want to change its value. Bring down the first term, 3x squared. Bring down the last term, minus 6. Now that this is a 4-termed polynomial, we can factor by grouping. Okay. All right, what's the GCF of 3 and 9? That would be 3. So the first term is 3 times x times x. And 9x is 3 times 3 times x. Over here, GCF of 2x and 6 is 2. So that's just 2 times x in the first one and 2 times 3 in the second. What do they have in common? This has a 3 and an x in common. So I'm going to factor out 3x from the first binomial, which leaves me with x minus 3. Over here, they have positive 2 in common. So when I factor that out, I'm also left with x minus 3. Common binomial factor here is x minus 3, so that's the first binomial in our final answer. And once I factor that out, I'm left with the GCFs of the other two binomials, 3x plus 2. We'll do a quick mental check just to be sure. X times 3x, whoops, I forgot to clear my parentheses. Okay, pretend like that didn't happen. 3x times x is 3x squared. X times 2x is positive 2x, negative 3 times 3x is negative 9x, and negative 3 times 2 is negative 6, and negative 9x plus 2x is 7x. So we know we did it correctly. All right, that concludes this video. So again, to factor a trinomial with the leading coefficients, with supergrouping, you first multiply the first and the last terms. That will give you your new product to play the P's and Q's game. You use the P's and Q's to split that middle term because you're going from a trinomial with 3 terms to a 4-term polynomial, and then you factor by grouping. Now, keep in mind, this is only one of the possible methods for factoring a trinomial with a leading coefficient. The other methods are slip and slide and double cross. And if you are not a big fan of grouping or GCF, I highly suggest looking into those 2 methods. That is it for this video, and I'll see you next time.